Kay. I think maybe you have been speaking on all XMLPragues in past?
I'm surely not all, but quite a lot.
Yeah, okay.
But never mind that. Welcome to those of you who don't know me. My name is Michael Kay. I work for Saxonica. I set up Saxonica 20 years ago. It's now, we didn't achieve my objectives, which was to keep it to a 1 or 2 person company. So it's grown a bit bigger than that, but not too big. So it's still quite small and compact, and we'll introduce ourselves in the sponsor presentation tomorrow, I guess. The talk today is a mixture of a sort of Saxonica talk and a personal talk and a Qt4 working group talk. It's a personal perspective on an aspect of the work that we're doing, creating 4.0 specifications, 4.0 versions of XSLT, XQuery, and XPath, with very much a focus on the things that we're doing related to processing maps and arrays, which means, in practice, processing JSON. So let's give you a little bit of background on that. The 3.0 specs, which came out in 2017, don't we have fun when time flies? So they introduced maps and arrays as data types, rather more thoroughly in XQuery than in XSLT, because XSLT was designed to work with XPath 3.0, which didn't yet have arrays in. So the support for arrays in XSLT 3 was a little bit incomplete. But in fact, it was all a little bit incomplete. And that's why I say many gaps in the functionality. I gave a talk in XMLPrague in 2016. Again, seems an enormously long time ago. And in that talk, I explored some use cases of processing maps and arrays and JSON structures using XSLT3. And in preparing that talk, discovered and presented some of the gaps in the functionality and how some things were actually quite difficult to achieve. And those use cases have motivated some of the work that we've been doing in the 4.0 specs to try and make some of those basic operations rather easier. And so part of the purpose of this talk is to show you what progress we've made in solving some of those use cases. A reminder, though, of why we introduced maps and arrays. There were probably sort of 3 strands to it. It started with the fact that XSLT 3.0 had a major objective of supporting streaming. Streaming means that you produce the output as you're processing the input, so you don't have to read all the input until before you can start producing any output. That means you need some kind of memory, because typically you need to remember what's happened earlier in the document, and that memory has to be flexible in its data structures, and it has to be efficiently updatable. And so we introduced, but efficiently updatable within a functional, within the context of a functional language where state is immutable. So you have to produce new maps efficiently from old maps, but as an incremental change. And so maps were the data structure that we added to the language to support streaming. And then we realized if we do maps for streaming, we can also, we've got half the work that we need to support JSON, because during the process of developing XSLT3, JSON was becoming a lot more important. And so there was well-developed support for maps in XSLT3 in the beginnings of support for arrays, which are the 2 data structures that the JSON supported that XML didn't provide us with. So we got quite a long way with 3.0, and maps and arrays in 3.0 are extremely useful. But when you come to operations on trees of maps and arrays, such as you get when doing full-scale JSON transformations, you find there are gaps, and some of those gaps we're trying to fill. That's part of the Qt4 project. Again, a couple of years ago here in this room, I introduced a project for starting 4.0 specifications. That project took a while to get underway, partly because of COVID and things, but partly because I'm not very good at starting projects. So Norm took over project managing it, and it rapidly gained acceleration when he started managing it, and I focused on the technical side. That project is doing a lot of things. We've made about 500 individual PRs to the specs, changing sometimes very, very minor details, sometimes fixing bugs in 3.0, some major new features, and I'm just focusing on a small number of them. The things I'm talking about today aren't necessarily stable in those specs yet. They aren't necessarily even in the baseline spec. I think there's a reasonable amount of consensus on, sort of 95% level consensus that we're going to have something like this, but it could still change before we put it in. I'm going to show you some things that are implemented. The paper also talks about some things that aren't implemented. So we're very much talking a snapshot of the current state of play, which will change before we get to final specs. 3 points I cover in the paper. Firstly, navigation. How do you navigate trees of maps and arrays? In other words, navigate JSON structures. But remembering that the XSLT model, the XQuery model for maps and arrays is more general than the JSON model. It's not just JSON, because you can have, for example, have maps that contain nodes. You can have maps that contain sequences, and so the data model is rather more orthogonal in terms of mixing bits of XML concepts with bits of JSON concepts into a single unified data model. So it's a generalization of both the XML model and the JSON data model. So navigation, and then what I call point update. You might think of it as in situ update, but in situ update implies mutability. By point update, what I mean is small changes to large data structures within the context of a functional model, where what you get from an update is a new version of the structure. And one of the key things one wants to achieve there is the kind of benefits that you get with functional data structures, where making a small change to a large structure is cheap. It is proportional to the size of the change rather than proportional to the size of the data you started with. One of the problems with doing XML-based transformations, if you want to do something like something we've also published papers about, how to write an XSLT compiler in XSLT, you find you're doing 5 phases of transformation, and some of those phases are doing very small changes to the structure, but making a small change to a structure with XML means copying the whole thing over. And the reason for that is things like node identity and parent pointers. You don't have node identity and parent pointers with maps and arrays. That gives you a different set of problems. You want to retain the benefits of doing efficient, constant time updates, and to eliminate the problems that gives you of not being able to navigate upwards in trees. So that's part of the theme of what I'm talking about here. Then the third item is bulk transformation, by which I mean recursive descent transformation in the traditional XSLT style. And I talk about that in the paper, but I'm not going to talk about it here in the talk this morning, because I decided for 2 reasons. One is I decided I hadn't got time, and the other is that there's actually a bit of a disconnect between what I think is going to appear in the specs and what's currently implemented in Saxon. So I felt I couldn't demonstrate what I thought was the final result would be, and therefore it would only be confusing to demonstrate anything. So the paper gives you a snapshot as to what I think the spec will be like, and in Saxon we've got a variant of that we've improved on in the specs since. But I will talk about, also under bulk transformation, as well as the recursive descent transformation. I also include things like grouping and inversion and sorting, and I'll talk about a use case in that area, both from an XQuery solution and an XSLT solution. So navigation, there are basically three things we've done. We've added the double question mark operator, the query operator, as an analog of the // operator for navigating XML trees. We've got the ability to select items by type, and perhaps architecturally most significant, the ability to navigate upwards as well as down. So I'm going to sit down because I can't type standing up. I've learned from experience that the effect is somewhat comical. And I'm going to illustrate some of the navigational capabilities in Saxon's Gizmo tool. So I'm running Saxon's Gizmo tool from the command line here. Oh, it worked, hooray. A reminder what Gizmo does, it gives you it's an interactive XPath evaluator. So I can show 2 + 2, and it gives you the result, and I can show 1 to 5 .*2, and it gives you 2, 4, 6, 8, 10. So it evaluates XPath expressions interactively. And so I'm going to set a variable to an input document, and the document I'm going to load is it's a document that comes from the JSON path specification, which Alan Painter is going to talk about in the next talk, but I don't know if he's going to use that specimen document, but this is the one used for examples in the spec itself. Whoops. Did I misspell it? Yes, I left out the JSON. So if we show the contents of that variable, I'm not sure how much will show on the screen on this size. Not very much. So it's a ridiculous document, comical document. It's totally absurd, but it's illustrative of the fact that we often have to work with comical documents in real life. So it's not realistic as you might be a badly designed document, but it's not totally untypical. So we've got a store with 1 bicycle and 4 books, which possibly is a little unrealistic, but it does help that they fit on the screen. Now what we can do in the 3.1 spec already is to do something like show $in store. Can I spell bicycle? On a good day, I can. So the question mark operator is the analog / when you're navigating XML. It just goes down one level. But one should note immediately that the names here fulfill a rather different role from the names in XML. Your microphone stopped working. Okay.
So if you can maybe keep it here.
Okay. Thank you. Is that better? Yeah. So the names in JSON fulfill a different role from the names in XML. In fact, names in XML fulfill 2 roles. Sometimes they're naming the kind of object you've got, like this thing we can see here would be called a book. In JSON, it hasn't got a name. The properties of the book have names, and those are a bit more like attribute names in XML, or you might use XML names for the properties and name the properties. But the other thing is that they name the object type. So element names are sometimes types of thing, and they are sometimes the relationship of that type of thing to the parent kind of thing. So the names have a different role, and in particular the books here are unnamed. except that we've named the set of books book, which is confusing. So this document has an array of anonymous objects, and the array of anonymous objects is called book rather than books. So, bear that in mind. One thing we've added, the simplest thing we've added is that you can now abbreviate that to show $in / bicycle, and it bypasses the immediate stage. Let's remind ourselves why that's useful. It's useful for a number of reasons. One is that the path might be very complex, and it's hard to get it right, and it's just noise, and so it's an abbreviation capability. You don't have to put in the detail you don't need. Another is that the path might differ between different bicycles. So you might have different bicycles at different places in the structure, and this finds them all regardless where they are. I know I give a third reason in the paper, but I can't remember what it is now. So that's the first thing we can do. We can go straight down, and of course we can also go further down from there. We can find the prices of the bicycles like that. Now there's here a difference between XML and the JSON model. If we do this, we've got 5 prices there. We've got one is the price of a bicycle, and the other 4 are prices of books. From those numbers, if it was XML, we'd be able to navigate from those results and find out which price was which. We'd be able to ask what's the parent of this price? What kind of thing is this the price of? With a pure JSON model, we don't have any upwards navigation. Therefore, you've just got a set of 5 numbers here. You can only manipulate them as 5 numbers. You can find the average, you can find the max, but you can't say, are bicycles more expensive than books? But I'll show how we've tried to solve that problem. Some of the other things you can do with this, of course, you can find the average by pumping that into a function. Again, the arrow operator is there in 3.1, and it can be used in this context, so the facilities work together. Then the next thing we've done is that you can talk about types. You can select a bit more selectively. So to illustrate that, we can select all the things that are of type record, title, author, star. The books, remember, don't have a name in JSON. We can't ask for individual book elements because these objects are anonymous, they're unnamed. So instead of using the name of the object to find them, what we can do is we can find them by structure. We've introduced the new data type, record, title, author, star. That's matched by any map that contains a title and an author and optionally anything else. So anything that matches that pattern of having a title and an author and possibly other things will be selected by this predicate, which is, if you like, a substitute for being able to call that a book. We haven't got a name for it. We could actually, not showing this here, but we could give that structure a name and just say, find me the things of type book. But that's just a macro for saying, I'm going to call anything that's got a title and or an author, I'm going to call it a book. So it's duck typing. If it's got a title and an author, it must be a book. And of course, we can then combine that with other things as well. So if we want to only get parts, we don't want the author, price, ISBN, category, and title, but only want a couple of the fields. We could filter the maps that we get out and say we're going to select the ones that FN of key is a shorthand in 4.0 for function of key, and we're going to select those that. Will you be able to read this when it goes off the screen, hopefully? Author, title. I've got that wrong. Yell at me when you see a spelling mistake. I've got to close that, and I've got to close that. So it hasn't, yes, right. I did that mistake before, and I've forgot how I corrected it. Yep, I used the wrong arrow operator. The reason is I've got a set of maps on the left. I want to apply that map filter function to each one of them, not just to the set of them as a whole. So we've got a new operator in 4.0 that says apply the function to every item in the sequence, which is this wonderful equals bang arrow operator. And that then gives me a set of 4 maps, which is the result of filtering the original maps to only select some of the fields of them. I can also apply a mapping function to each of those. So, for example, I've there got my set of 4 maps, and I'm now going to process each one of them by creating a new map. You're used to writing map, the map keyword followed by curly braces to create a map constructor. The map keyword is now optional. You can just use bare braces to construct a map as in JSON itself or as in JavaScript. So I can create a new map that contains the author and the title, like that. And that is just another way of creating maps that contain a selection of the fields. And of course, I can use that type syntax to not just to select maps, but I could, rather than selecting all the prices, I could say, give me everything of type XS double, if that was a useful thing to do, and it gives me all the numeric values in the data and so on. So I've got a lot more flexibility now in how I process and filter the data. Let's look a little bit more at how we do the upwards navigation. So when I talked here last about the problem of parent pointers in JSON and how to do upwards navigation, I presented a model for it in which we don't add node identity and parent pointers to the data, but we remember how we navigated downwards so that we can retrace our path and come back to and follow not the intrinsic parent or owner of the data, but ask a question, how did we get to this data? So we annotate the results of this path expression, this query-based path expression, with not just the values that we found going downwards, but the path by which we found them. So there's additional annotations on the result, labels on the result, saying how did we get here, and knowing how we got here enables us to go back. So if I do, so basically I can qualify the question mark now by saying rather than just the values, I want the entries that we've found. And if I do that, then we found that what we found is not the strings, but we found a selection of records that contain a key, which is sometimes ISBN, sometimes category, sometimes title. So I can find all the string-valued things with the name of the property that was selected, the actual value of the property, and then we see I've got some functions available as well, which enable me to go back upwards through the tree. And to show how that can be used, I can show. I'll do the prices this time. No, I need entry price. And then I'll select the ones that are the prices of something that has an ISBN. So I've now only got 2 items selected. I've still got the full entry details, but this time I've selected the ones that, by filtering upwards, looking upwards at the parent and saying, is this parent an object that has an ISBN? And of course I can then say I actually want to display the price by showing its value, which gives me the actual values. So I've got some intermediate data that gives me extra navigation capability. How are we doing on time? I'll skip from there to talk about updates. Whoops. So the first use case that I did in 2016 that showed this was difficult was to take a fairly similar kind of JSON data set and say, how do we increase the price of all products with a particular keyword by 10%? And I explored various ways of doing that, and there are the 7 pages of the paper from 2016 that describe the solution. I found, in fact, the easiest way of doing it was to translate the data to XML, do the query in XML, and then convert the XML back to JSON, which is incredibly long-winded, but it was the best I did it directly, and the reason it's 7 pages is that there are actually 2 solutions there. But the easiest solution is to convert it to XML, do the transformation, and then back again. I thought I had another slide there, but not so. The solution here, in the 4.0 spec, I need to load a different document. Let's just show you the basic syntax of update. So there's a new update expression, which might not have exactly this syntax. We're still playing with it. So we've got an array there. We'll select the second item, and we'll replace its value with 10. Whoops. I've got to say update array. And it gives the updated array. Now, of course, there are simpler ways of doing that, but when you get to deep update, it becomes more interesting. Now, hopefully, the syntax of that update expression is very, very easy and intuitive to understand. The semantics of it are actually extremely complex. Because to make that update work and return not just the updated value, but the updated array, you've got to consider the fact that a number of things might have changed. You've got to consolidate those updates. You've got to propagate them upwards back to the root of the tree of the maps and arrays, and then return an updated version of that contains all the individually updated leaves. And to do that, you've got to use the same kind of technique of tracking how you got down to the leaves that you've updated. You've then got to track back upwards, find when you've made 2 updates to the same container, apply all those updates to the container, then propagate them upwards again. In fact, the current spec isn't defined that way. The current spec is defined in terms of a top-down recursive descent transformation, but the implementation works bottom up in that way. It's actually been in Saxon for a while, but with different syntax. Hopefully the new syntax is much clearer and more intuitive. So that's the basics of how update work. And if I do an example of that, I'm short of time inevitably. But let's load another JSON document. And we'll show you that document, which is the same one as I used in 2016, where we've got a number of prices of things. And I can then bind another variable out to the result of an update. It's an array of products, so I'm going to replace some of them. I'm again going to select by type, and I'm going to select things that have tags and prices. And I'm going to select the ones that have ice among the tags, because that's what the query said. I don't know why it did, but so I'm updating selected prices, and I'm multiplying them by 1.1 to give a 10% increase in those prices. It's done that query, and if we show the result, then you obviously memorized the price, and it wasn't 1.375 dot that. So it's updated those prices. It's updated that price, and it hasn't updated the second one. So that's done what was needed. So that was the first use case. So it's now down to a single line command from that 7 pages of text. The second use case that I tackled was, given a list of courses with the students on each course, how can we build a list that contains all the students with the courses that they attend? So that's a classic hierarchic inversion kind of query, a grouping query. I won't type this one in, I could, but I'll just show you the result on the screen. It's a bit too much typing to do. But the XQuery solution to this now is that we construct an array for every email at any depth in the original structure. We group it by the value of the email. We order it by the grouping key, and then we return a map that contains the email address and the set of courses. And to find the set of courses, we have to go upwards to the ancestors. So remembering those aren't ancestors intrinsic to the data. They're the ancestors in the sense that this is the route by which we found the data on the way down. We're retracing the steps upwards to find the course that each student belongs to. That's the XQuery version. The XSLT version is extremely similar. So it does grouping. It selects the courses. It groups them by the entry email. It sorts by the current grouping key. Then constructs a map containing the email addresses and an array of the courses, again using the ancestor axis. So I think that's probably where I will stop. I'm not going to talk about templates over maps and arrays because I haven't got time, but there's a lot of material in the paper which I encourage you to look at if you're interested. Let's take questions there.
So we can take questions, or we can continue for 5 or 10 more minutes because we started later, so it's not your fault. It's
great.
So, question from Stephen.
So, from a syntactic point of view, is there a particular reason why you have to use the parent function rather than, let's say, /...
Slash has all sorts of semantic baggage with it. Probably could have made it ? There is a reason for making it a function. The reason for making it a function is to avoid getting into the position where maps are cyclic, where maps contain references to themselves. Because without identity, that would make the recursive expansion of the map infinite. And so we've avoided that by making sure that the owner information is only accessible via a function. And that prevents that infinite explosion.
Okay, thank you. Some other question? From John Snelson.
So, I already held this opinion, but adding more syntax that's specific to maps and arrays just highlights the fact that really we're designing a different language to work with JSON and arrays. It's not XPath, really.
Yeah.
And I just wondered what your thoughts on that were. I kind of regret the direction that XQuery went in, and I would much rather have struggled to come up with a good XPath syntax that also worked over them.
Yeah, I mean, we've got a hybrid data model that's in some ways, it's a blend of XML and JSON and not a unification of XML and JSON. And that's reflected in the fact that the language is a blend of different capabilities addressing different parts of the data model rather than a unification and integration. The data models are sufficiently different that I think that's almost inevitable given what we're trying to do. I don't see I recognize the problem and I don't see an easy solution to it. It does derive from the fact that the data model itself is lacks the kind of orthogonality that one would ideally like. And part of that is, that I start the paper by saying XML trees always have owner pointers. JSON trees never have owner pointers. There's nothing intrinsic to the syntax of XML or JSON that says the tree models should be so different. But yet that's part of the culture, part of the background, is that with XML we expect to be able to navigate upwards. I speculate that the reason why it's required with XML is that it's needed, particularly with recursive data structures. XML is focused on text, text is recursive, therefore the needs of text processing generate a need for parent navigation, which doesn't exist in the data world. So you are blending cultures and force-fitting them together in a way that where there's no grand unified theory of things.
Okay, thank you. Some other question? Do you see someone, Mohammed? Okay, so thank you very much again then.
Okay, thank you.
Disconnected before it falls.